Okay, record. First thing I have decided that probably the easiest way to keep track of deadlines and everything with the capstone analysis project is for me to create a topic in Moodle or Moodle PowerShell on the analysis capstone project and put your assignments there stepwise along the way with the deadlines in Moodle. And so during my office hours later this morning, I will create the first one. Just as a heads up, by Friday, I will want you to scan and upload or download from IMSLP and then upload to Moodle your score for the piece that you'll be doing. And then I can look over those during JazzFest and make sure that they're going to work for you before you get too far down the road. Set you up for success from the beginning. So keep an eye on Moodle, and that will be up there. Now to the topic du jour. We saw some interesting modulations, chord progressions, in Chopin last week. You may recall the prelude in E major, modulated from E down to C major, down to A flat major, and then ended up back in E major. And then his prelude in E and A minor actually started in E minor, modulated to, this one went up, G major, and from there went to B minor, and then didn't go to the D major that we were expecting. Not D major. But we were expecting it to go for D major, and that's because there are patterns involved in this. And pieces of music in the 19th century start to follow these patterns to the point that a theorist named Hugo Riemann makes them a part of his theory of functionality. So I'm going to play a little bit of a reduction of Liszt here. I'm going to take out all the shimmering triplets because there's no way I'm going to play that. But And so we've gone through, in the course of this, some very interesting key progressions. Start off in D major. Kind of held out that chord, moved through some motions with the melody. The next chord shifted us to B major. Continued on for a bit, the next chord shifted us to E flat. From there it shifted into C and then ended up in E at the end. Let me play that in a more compressed fashion than I did. So I moved from D to B to E flat to C to E. colors, aren't they? Let's take a look at these progressions. Oh, let's see. I set this way so I don't have a bunch of lines. All right. Start off in our nice D major. All right, we're going to follow our rules for good voice leading. We're going to keep parsimonious voice leading, keeping common tones whenever possible, moving other voices the least amount possible. All right, so we're going to go to B major instead. So think over a B major triad. Which notes are the same? Or which note? The F sharp. They both have an F sharp in them. So let's get a common tone. What changes? A goes to B.
And then the D goes to D sharp.
D goes to D sharp. We've got a little bit of a chromatic shift happening there. Nice smooth progression. Not much had to change to make that happen. Playing on the piano is super easy. All right, let's go ahead and go to E flat major. First of all, do I have any common tones? If I use an enharmonic reinterpretation, let's move into the later part of the 19th century. Well, equal temperament has become standard enough that we do now consider D sharp and E flat to be the same pitch. So we'll use that, stays the same. What shifts? B becomes B flat. F sharp goes to G. By the way. Half step shift, half step shift. Very smooth. All right, C major. G stays the same. Good.
Up by a half step.
The
To the C. The B flat goes up.
Yeah.
Whole step to
Whole
C.
step, sorry, yeah.
Yep. And then the E flat
Goes up a half.
Goes
goes
up
up a half step.
to the
Now
E.
here's the half step to the E. Yes. Again, a very, very smooth progression. And then we'll end by going to E major.
The E stays the same.
Hmm?
G goes up a step to G sharp.
G is a G sharp, correct.
And C goes down to B.
C goes down to B. And so we've got this very, very smooth series of chords, or what David Lowen likes to think of as transformations. We transform this into this, which transforms into this, which transforms into this, which transforms to.
Sounds like it would be on like almost like a sci-fi movie kind of thing.
It sounds like you would hear this in movie music, doesn't it? A lot. Yes. Film music is replete with this late 19th century chromaticism going on that we see kind of starting more or less with Chopin, but then continuing with Liszt, Mahler, does this, Wagner, all over the place. And so in 1984, Brian Heyer writes an extremely influential dissertation that creates the field of what we call neo-Riemannian theory. And it's the best way of explaining how all this works, particularly because it makes it visual. We musicians tend to like visual representations of things, make it a little bit less abstract. So we're going to explore some of these transformations a little bit. And to visualize things, we're going to create what Heyer called the tone nets. Tone nets, which is to say a network of tones. Tone network. And this boils out of Riemann and other people writing in Hauptmann, a lot of 19th century dualists, even Schoenberg in his tonal writings as he's teaching how chords are related to each other. They have tables of chord relationships. Weber as well, Max Weber, yes. And so we can kind of visualize the most important relationships in tonality and draw them out on a network of notes. So let's go ahead and do that real quick. Let's start with a nice C in the middle. Everyone likes C. All right, thinking about triads. What are the most important intervals in our tonal music? Thirds and fifths. What types of thirds specifically? Because we've got two of them.
Major.
Major and minor. Okay, so what we're going to go ahead and do is we're going to go ahead and represent major, minor, thirds, and fifths, and put a relationship of notes here and build up a little network of them accordingly. Oh, we'll go ahead. In my master's thesis, I proposed the convention of doing the smallest interval along the horizontal, followed by the next one on the vertical. So we'll build it that way. Up a minor third from C, E flat. Up a minor third from E flat, G flat, good. Up a minor third from G flat, B double flat, good. I hit double flats, I'm gonna stop because we don't want to go too far down that road. We end up in triple flats before we know it. Let's go down minor thirds, down the minor third from C.
Oh.
Close. A.
Oh, okay.
Down a minor third from A. It's hard to think down a third.
F.
F.
Sharp.
Sharp. Down a minor third from F sharp. D sharp. Down a minor third from D sharp. Close.
B sharp?
B sharp. Yep. Oops, not D. B sharp. Down a minor third from B sharp. G double sharp. Yes, we'll stop because we hit double sharps and we don't want to keep going that way. If we do, we're going to run into triple sharps before we're done.
Gonna be F double sharp?
What? Get rid of the sharps. Get them out of your mind.
Right.
B down a third is some type of a G. B to G sharp is a minor third. Got a sharp on both. Yeah. Double sharps just make our brains hurt. We don't love double sharps and double flats. We don't spend much time playing music that goes into those areas. So we'll stop at that point of the tonance. All right, let's build our major thirds. C up a major third. E. E up a major third. G sharp, good. G sharp up a major third. B sharp, good. I've got room to squeeze in exactly one more, which is good because we can go up a major third from B sharp and hit D double sharp. And so if I keep going that way, I'm going to run into double triple sharps really fast. We'll stop, we'll go back down a major third from C.
A flat.
A flat. Down a major third from A flat. F
Flat.
flat.
Oh,
F A flat minor third, so we have to go F flat to make it a major third. Down a major third from F double, or I'm sorry, F flat.
D double flat.
D double flat. Stop. Go away double flats. All right. So I've got minor thirds going this way. I've got major thirds going this way. This one's perfect fifths. C up a perfect fifth.
G.
G. G up a perfect fifth.
D.
D, good. D up a perfect fifth.
A.
Let's go one more, why not? D up a, A up a perfect fifth.
E.
E. C down a perfect fifth.
F.
F, good. F down a perfect fifth.
E flat.
B flat down a perfect fifth.
E flat.
E flat, excellent. That's as far as down as I came, so I'll stop there. But if we kept going, we keep going down the flats. All right, now there's an interesting thing that emerges as we do this, because now I can start to fill in every horizontal axis is going to have a minor third, which means E up in minor third is G. Ah. G up in minor third is B flat. B flat up a minor third is
E flat.
D flat, yes.
Oh.
E down a minor third.
Is that just
E down a major third is C, so it's going to be C sharp, making it smaller. C sharp down a minor third. By the way, there are other ways of figuring this out if you don't like thinking to do.
no,
Sit
it's
there.
stay sharp.
Because look at this, E flat to G is a major third. G flat to B flat is a major third. B double flat to D flat is a major third. So if you like, think up a major third from F sharp gives you A sharp.
Oh, first one.
Or maybe you prefer perfect fifths because D sharp to A sharp is a perfect fifth. And F sharp to C sharp to G sharp are perfect fifths.
Always holding my.
And A to E, what would come next? A, E,
Oh, it's perfect.
perfect fifth,
B.
B. And so however you fill this in, whether you're doing minor thirds, whether you're doing major thirds, whether you're doing the perfect fifths, it all lines up. It makes a very, very clean network. I'm going to go do perfect fifths here. A flat, E flat, B flat, F. A, E, B, F sharp. F sharp will be followed by C sharp. F sharp, G sharp, G sharp, C, G, D. A. B sharp would take us to F double sharp, which is also a major third from D sharp there. I'll get rid of this hanger on here. Fill in some more. D sharp, A sharp, E sharp would be next. So many double sharps on this side. E, A, D, G, C. A flat, D flat, G flat, F flat would take us to B double flat, F sharp, B, E, A, D sharp goes down to G sharp, goes down to C sharp, B sharp takes us to E sharp, B sharp, F double sharp, C double sharp, we'll stop on this row because, yeah. G double sharp, D double sharp.
There's gotta be at least one triple or double flat.
Absolutely not.
F flat, would take us to C flat, then G flat. D double flat would take us to, oh, this is such a pain, this one. This is gonna be our double flat one. We'll do it this way, major, minor thirds. F to A flat is a minor third, so F flat to A double flat is a minor third, and then my double flats will stop. C to E flat is a minor third, so C flat to E double flat is a minor third. And we'll stop, because it's obnoxious.
Where's your sense of bench?
All right, let's simplify our lives here. Let's zoom in here. Just one of the horizontals, one of the nice horizontals. Let's see if we can simplify our life. All right, somebody tell me something about the pitches on this line. How many different pitches actually are there?
Are we talking?
There's only a limited number. It's not a lot. It's not as many as it looks at first place.
It's just a diminished,
There's the diminished seventh chord built on here. And there are four different pitches because A is enharmonically equivalent to G double sharp and B double flat. B sharp is enharmonically equivalent to C, or the next thing that would come out would be D double flat. D sharp and E flat, F sharp and G flat. So it turns out we've only got the same four pitches repeating over and over and over. Now, in order to shift now from a just temperament, where there is a difference between G double sharp A and B double flat, we're going to shift into equal temperament. When we do that, there's always an issue. And it comes down to the notes that are called sharp and flat. Am I going to call something F sharp or am I going to call it G flat? We're going to switch our notation system to get rid of that problem. We're going to start using what we call pitch class numbers. So this is a notational standard invented by I believe my academic grandfather, Alan Fort, who was my advisor's advisor. When he released his groundbreaking treatise on structures of atonal music in the 70s. And what we're going to do is we're going to translate all of our letters into numbers instead, so I don't have to call something sharp or flat. Now we're going to think of it, because there are 12 pitches in an octave, the clock is a really helpful visual aid here. So I'm going to go ahead and construct the clock here. 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Couple of other things I'm going to do really quickly, because if I'm writing a string of notes down using numbers, and I'm writing really fast, if I write this, am I writing 12, 12, 1, 2, or am I writing 1, 2, 1, 2, 1, 2? What's going on here? We're going to try to get rid of some of these double-digit numbers. So instead of starting at 12, what's our center pitch that we always think of? C. We'll make C the center. And then we're going to define these as being that many half steps above C. So C is 0 half steps above C. We're going to start on 0, and 0 is C. That got rid of the 12. We'll get rid of the 10 and 11 by calling them T for 10 and E for 11, respectively. All right, let's start with our notes that don't have sharps and flats on them to construct easily. D would be what number if C is 0? 2. Good. E would be what number?
4.
4, yeah. Whole step. Whole step. And F would be 5. There's our half step, 4, 5. All right, G,
7.
whole step. A, whole step to 9. Whole step to B, which is the same as a half step down from C. 11, yes. That's how I would learn pitch class numbers, is I would start by learning my C major scale and be able to translate from that from C, D, E, F, G, A, B into 0, 2, 4, 5, 7, 9, 11, 0, and be able to construct that clock. Now the handiness comes in, because now instead of calling a note, well, do I call it a D sharp or do I call it an E flat? I just say it's a
3.
3. Yeah, and I don't have to worry about flats or sharps. I'm just worrying about how many half steps away from C it is. So I'm going to go over here now to my tone nets, and we're going to replace the note names with pitch class numbers. Start with the easy one right here in the middle. C, 0. E flat,
3.
3. Good. G flat.
6.
Mhm. B double flat,
9.
9. Good. B double flat, 11. A, 9. F sharp, 6. D sharp,
3.
looking for pattern with a number without even having to think too hard about what B sharp is, it's going to be what?
0.
And G double sharp is going to be 9. Because it turns out when I take a number and I go up a minor third, I'm going up how many half steps? Zero to 3 is 3. Suddenly the math becomes really easy. 0 plus 3 is 3, plus 3 is 6, plus 3 is 9, plus 3 is 12, which is the same as back to the top of the clock, takes us back to 0. We just keep going over the clock. 0, 3, 6, 9, 0, 3, 6, 9, 0. And that's our x's, and it goes around, and it's a perpetual circle for infinity, doesn't it? I keep going up and down those pitches all day long. Circle. All right. Let's construct a vertical axis. 0 up to E. E is a what? 4. Which means that I can now think of my vertical axis,
Oh my god, this is just multiple
or I'm just adding 4 to it. A third is 4 half steps. So that means G sharp is going to be 4 plus 4 is 8. And B sharp is going to be 8 plus 4 is 0, because 12 takes us back to 0. And 0 plus 4, D double sharp is 4.
This is great.
That's fantastic. Get rid of all those double flats, double sharps. 0, 4, 8, 0. I think I can handle that. All right, go backwards. 0 down 4. 8. 8 down 4.
4.
And 4 down 4.
0.
Yes, indeed. By the way, I already know how this line goes, don't I? This is a 0. What's the next number? Going horizontally.
3,
3. Followed by
6,
followed by.
9.
And so it doesn't even matter that this would have been something like triple flat, whatever. We recognize it wraps around. And going this way as well. 0, 9, 6, 3, 0, 9. Oh, here's another one. 0, 3, 6, 9. 0, 9, 6. Who cares about all those double sharps? They're just 9s and 0s. And of course, the 0 axis goes 0, 4, 8, 0, 4, 8, 4, 0. Yeah. Okay. Let's fill in our missing ones. 4 plus 3.
7.
Plus 3.
10.
10, which we were going to write as a
T.
T. All right. 10 plus 3, don't wrap it yet. Just do 10 plus 3. 13. 13 is bigger than 12, equal to or bigger than 12, so I need to subtract 12. 13 minus 12 is 1. And that's how you drop it back down to 0 to 12 range. So you just keep subtracting 12, or if you're in negative numbers, adding 12 until you get back into the range. So 10, 1. Going this way, 4 minus 3, 1. And now we recognize the repetition. 1 minus 3 is negative 2, which plus 12 makes 10. 7, 4, 1. Oh, there's a 4, so this must be a 1, 4, 7, 10, 1, 4, 7, 10, 1. And there's a 4. 1, 4, 7, 10, 1, 4, 7, 10, 1. Almost there. We almost have our tongue that's constructed. 8 plus 3.
11.
11. All right, either. 11 plus 3 is 14, which minus 12 is 2. And 2 plus 3 is 5. Okay, 8 minus 3?
5.
5. Minus 3?
2.
2. In between 2 and 8 makes
E.
or 11, yes. 5. And we'll fill in that row as well. 5, 8, 11, 2, 5, 8, 11, 2, 5.
I feel like E should have been the to avoid confusion with the pitch. Like a big old V.
Yeah, different people come up with different ways of doing it. Some people do what's called dual decimal, which is where you count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B. That's a computer programming thought. But then you really, I mean, the nice thing is that B is B. The bad thing is that A is 10 and 9, and it's confusing that way. There is really no perfect solution. Christian.
I don't want to sound like an algebra flunky, but what kind of practical application is this
Ah,
idea?
that's where we're going next.
Oh,
Is it chords?
That's where we're going next. We can represent chords on this thing. Once we've built the tone nets, we've just been building the tone nets, which is to say minor thirds, which is up and down 3s this way. Major thirds, up and down 4s this way. But you're right, the important thing we're interested in as musicians is how do we use this. Let's have some fun. Let's represent our chords. What are the 3 notes of a D major chord? D, F sharp, and A. Good. What are the pitch class numbers for D, F sharp, and A? D is
2.
2. Good. A is F sharp is 6. I'll take it. And A is
9.
9. All right. What I'm going to do to represent the chord visually is I'm going to connect the 3 notes that are in the chord. 2, 6, and 9. I now have a visual representation of a D major chord. Okay. What are the notes of a B major? I've already got my F sharp, which is 6. B would be
11,
11, good. D sharp,
3.
3. All right, so I'm gonna come over and I'm gonna find a chord that has 3, 11, and 6 in it. I'm gonna start somewhere else because I see which way the pattern is going. And I don't want to run off the end. I'll start here. 11,
3,
3,
11.
6.
Ooh.
All right, E flat. Well, notice the D sharp is a, or E flat is a 3. B flat is a
10.
10. Oh no, I picked the wrong corner again. And G is a 7. I'm going to redraw my tone nets yet again. Now I'm just going to start down here. This was D major. This was B major. And 3, 7, and 10, E flat major. All right, C. Well, I know the G is a,
7,
C is
0,
good. E is
4.
4, 0, 4, and 7. Would anyone like to predict where the next triangle goes?
I don't think it goes up because the stitches don't interact. They don't move the same way. Wait,
The T, the.
oh, they do. It just goes up, doesn't it?
Let's look. The E is a 4, B natural,
E.
G sharp, 8.
8.
Yeah, it is. I got confused because.
The specific voice leading.
Flat.
The specific voice leading confused you, but as I draw this, now we suddenly see there's a pattern here.
So then is the next one going to be 1, 8, 1, 5?
The next one would go here, wouldn't it? You can predict where the next note of the pattern is, which would be a what chord?
C sharp.
Could be a C sharp major or a D flat major, depending on how you write it enharmonically. But we can in fact predict where the chord progressions are going. There is a pattern to them. And the pattern isn't down fifths or down third circle of fifth circle of thirds Romanesque as following fifths type sequences, as has been seen in much tonal music. The pattern is this. And the cool thing about the Dubnets then, Christian, is it lets us see patterns that might not be immediately intuitive to us. It's really cool, isn't it? Let's do some Chopin. Chopin modulated from E major to C major to G sharp major, back to E major again. We'll do this one in green, shall we? Somebody tell me the notes of an E major chord.
G sharp, B, G sharp.
Yeah, E, G sharp, and B, which is the numbers
4, E,
4, 11, and 8. I'll grab this one right here. 4, 11, and 8. C.
0,
0, 4, 7. A flat, or yeah, A flat, because he didn't modulate to G sharp, he modulated to A flat.
8.
8.
8, yeah.
C is
0,
0. E flat is
3.
3. And of course, at the end, he came back to 8, 4, 11. There's a pattern to how Chopin went through his keys.
So before this system came out, this was more just kind of being like, okay, I'm going up a fifth, and so.
Well, composers did things that sounded good.
Yeah.
Theorists always come along behind afterwards and try to figure out what's going on there. Why did that work? And Brian Heyer kicked off this whole branch of, that's called Neo-Riemannian theory. I'll write that on the board. Your reading that I posted on Moodle this morning, so I'll try to have that read by Wednesday, is an introduction to Neo-Riemannian theory from the first undergraduate textbook that had a section on Neo-Riemannian theory. It came out a few years ago. Oxford published my review of it as their advertising campaign. But it's really cool. We had another one that Chopin did. He started in E minor and went to G major, went to B minor, and we expected him to go to D major. He didn't. Let's trace this one, E minor. I haven't written any minor chords up here yet. This will be interesting.
Well, it's just the same thing as the E, you just pick the third.
Yeah, so not 4, 11, and 8, but 4, 11, and
4, 7, 11.
7. Okay. Let's draw this one in red. 4, 7, and 11. It's going to be in the way of other things no matter where I put it, pretty much. Unless, I can sneak it in there, maybe? Yeah. Know something now. Major triads are represented in the tonettes as triangles that go that way. Minor triads are triangles that go the other way. So I can already tell from the shape of the chord whether it's major or minor if I just draw the notes on there. Cool. All right, G major has what notes?
G major.
7.
7, G.
And then you go up 5, and you go up 4.
We've got our B,
11,
which is 11,
and then
G, B, and
And then 2
3.
for the D.
2 for the D. 7, 11, and 2. 7, 11, and 2. B minor.
E is 11.
And then 1. Right? For D flat.
D flat.
Wait, no. B. I'm losing my mind.
2 for
2.
D. And
Yes.
then F sharp is
6.
That's right. That's right.
11, 2, 6. And we expected it to go to D major, which was D,
2,
F sharp.
5.
F sharp,
Oh, 6.
A.
8, 9.
We expected it to go to here, but he actually went to not 2, 6, 9, but he went to D sharp, F sharp, and A, which means he actually went to there, which is a diminished triad. As it turns out, diminished triads look like lines on the tonettes. There are all sorts of chord shapes that you can draw and do things with. People have done jazz analysis using Neo-Riemannian theory. Those are some really interesting looking shapes. But again, you can see visually, you can see the patterns that are going on here. What questions do you have floating in your head at this point?
You should write as a formula, I think, like n plus 4 plus 7. Well, that's not really a formula, but like to show how major works. Because I was just thinking of it as like you take 1 and then you add 4 to it, 5, and you add 3 to it, and then you get 8. And I think that's the easiest way to think of it.
Yeah, there's all sorts of different, it makes you rethink how relationships between notes happen. You might be interested if you want to work through some serious math on all this stuff. There's an absolutely fantastic book called The Geometry of Music. Yeah, some of you aren't going to want to read this. By Dmitry Timashko, who's the head of the theory department at Princeton. This is one of those books that every so often, specifically when he was talking about multi-dimensional chord motions, that I would read a page and stop and think about it for a couple of minutes and then go back, okay, I've got it now. So warning, that stuff, that's some pretty high level math. But Timochko is also one of the co-authors of the first ever music theory article that was published in, I'm trying to remember if it was Nature or Science, but it was one of the two leading science journals, which was kind of huge when that happened. And it was this, the geometry of music, and he actually talks about, and we'll talk about some of his stuff that I've pulled out and made a little bit more accessible for undergraduates. He thinks about, well, for example, we've used the term macroharmony. Timochko was the one who came up with the term macroharmony for a collection of pitches that kind of represents a scale or a key. And then he has some geometrical progressions put in where we are not moving through chords, but we're moving through collections of pitches, and think about progressions of macroharmonies, which is really cool. It's neat stuff. We've just started to scratch the surface of it because it's less than 40 years old at this point. Neo-Riemannian theory was invented in my lifetime.
Weird that it works so well.
Right, and it's intuitive. Like you get a tone nets. I'll upload one on the Moodle shell in case you want to play around with the tone nets at all. But you get a tone nets and you start, oh, let's see what this progression does and see if there's a pattern. You just start drawing out the chords and, oh, I see a pattern. It's super intuitive. It's like one of the easiest forms of analysis that there is actually. On Wednesday, we will talk about some of the common, what we call neo-Riemannian operators. They're common chord progressions that show up a lot in music that works under neo-Riemannian theory. As it turns out, they include everything that we learned about in common practice tonality. That is a subset. They're like, the common practice tonality uses like 3 of the possible operators of neo-Riemannian theory. So it explains all of common practice tonality plus some. And then when we get into atonality, my master's thesis shows how this works in atonal music. And Schoenberg is doing the same chord progressions, he's just not using triads. It's cool. So, we'll see you tomorrow.